Peter, tell me about the kinds of teams then that you assemble in order to accomplish it.
Right, yeah. So, yeah, there's a big difference between the kind of skills and team that you need to make a cognitive architecture successful or to make deep learning. So the majority of our team are actually cognitive psychologists and linguists. Now, of course, we concentrate on natural language conversation. So it's sort of understanding the mind of AIGO, our AI, to understand how it learns, why it doesn't learn certain things, what additional knowledge it needs to have. So it's all about understanding the thinking process, the learning process, and being able to teach AIGO, to teach the system the missing information or the missing skills that are there. Now, there is, of course, an underlying engine that needed to be engineered by software engineers as well. But that's work we've actually largely done over the last 15 years of building the core mechanisms. And that's really what you want. You want a very small core of code that gives you the ability to teach the system more and more information and skills. Whereas with deep learning, machine learning, it's all about having data scientists to have people who understand how to tune these models and their learning algorithms, how to clean up the data, how to format the data that they then use to teach the system. But it's a one-time teaching of massive amounts of data, and then you run these models. Hopefully you have a lot of computing power, and then it doesn't quite work, and then you can try something else, and they're basically experts at tuning them. But there's very little incremental learning, whereas in our case, it's building on top of existing knowledge. And then one of the other big differences, machine learning, deep learning is a black box. You basically don't know what it's doing inside there. It's just somehow the number crunching came up with this model, and that model can predict reasonably accurately or categorize reasonably accurately, and that's it, but you don't know how it's doing it. Whereas with cognitive architecture, if the system doesn't give you the answer you expect, then you can look into the brain, or you can ask AIGO in some cases, and figure out why why the cognitive architecture is giving you, a different result than what you expected. And then you can say, oh, okay, fine, it was missing this grammar rule, or it was missing this piece of background knowledge, or whatever it was.
Kind of reminds me of the old, give the machine a fish.
Oh, yeah.
Right?
Or teach it to fish.
Or teach the machine to fish.
It's a very good analogy, yes.